Hello, this is Mr. Huber. In this lesson, we're going to learn about factoring polynomials completely. Right, we're going to pull together the different types of factoring we've seen and make sure that we're doing all that we can to factor as much as possible for any particular polynomial. And the basic steps you're going to follow: first, always looking for a greatest common factor. Right? Then look for special patterns, difference of squares and perfect squares. This is a perfect square. We'll see some difference of squares as well. So always look for those special patterns. Then we're going to know how to factor a trinomial: ax squared plus bx plus c, possibly using the AC method or other factoring problems we've seen. And then factoring with four terms. When you're doing that, you're going to be grouping. So we're going to get this written in standard form. We'd have the x cubed, then the x squared, and then we're going to group parentheses around the first two terms and second two terms. So we want to keep in mind factoring by grouping when we see four terms. All right, let's look at some examples of factoring completely. So this first example, we have a common binomial factor. This doesn't happen all the time, but some m minus 3 and m minus 3, that's a common factor of this first term and the second term. So we can factor that out, and we'll have m minus 3 and then m squared plus 9, which are the other two factors there, and that's factored completely. If this was an m squared minus 9, it was a difference of squares, we might be able to factor another step, but this one, that's all we can do. All right, in number 2, first we want to look for a greatest common factor, always, and we have one here, so we can factor out a 4, and we'd have x squared plus 5x minus 6. So that's 4 is a common factor of all three of those terms. And then we can factor further what's inside the parentheses. Right? This is not using the AC method because our A value is 1. We just want to see what multiplies to give us C and adds up to B. So in this case, it's going to be a plus 6 and a minus 1. And then that 4, don't forget that 4 is still part of our factor, and we bring that down, and that's factored completely. All right, next, in number 3. And first we're going to look for a greatest common factor. And we have one here. Right? We can factor out from all of these terms a negative 3w. Okay, negative 3w is a common factor of all three of the terms. We're left with 2w squared. Okay, then we're going to have a plus 7w and a minus 15. Right? And now we're going to have to use the AC method because we have an A value 2 here. So the AC method says we're going to multiply A times C, so AC is negative 30. And we're going to want to find factors of negative 30 that add up to 7. So we're going to have 2w squared plus 10w minus 3w minus 15. And we're going to want to group those. So we're going to group two terms at a time. In this first grouping, we can factor out a 2w, and we'll be left with w plus 5. In the second grouping, we can factor out a negative 3 and be left with w plus 5. So we're going to have 2w minus 3. We're going to have w plus 5. And we also want to make sure we're bringing down that other factor. Without that, we don't have it factored completely because we wouldn't be including all of our factors. Right? So these multiply together and give me back the polynomial I started with. If I didn't have the negative 3w here, and I just multiplied these binomials, it wouldn't get me back where I started. I'd be a little short of that. I'd need the negative 3w as well. So we look for a greatest common factor, then look at what's left over and factor that further. All right, in number 4, we can look for a greatest common factor. There isn't one. You want to make sure that a greatest common factor is a greatest common factor of the entire polynomial. We don't want to go here and just say, oh, I can see a 2 in these terms, or there's some x's. No, it has to be common to all, in this case, 4 terms. And so we see 4 terms like this right at the start, we're going to group it. Make sure it's in standard form. So we have the x third, x squared, x, and the constant term. That's good. And then in these groupings, we can factor out, let's see, x squared here first. And so we'll have 3x and plus 2. And the second group, we can factor out a negative 16. And we're going to have a 3x and plus 2. And so we have x squared minus 16. And we have 3x plus 2. And we don't want to stop here because this is a difference of squares. It's one of our special factoring patterns. So you always want to factor completely and make that x plus 4 and x minus 4. And then the 3x plus 2. Right? So look for those greatest common factors, then look for special patterns, and look for factoring when there's 3 or 4 terms, depending on what it looks like. If it's 4, group it. If it's 3, you're factoring using possibly AC method or other things we've seen to factor those by what multiplies to C and adds up to B. If we're solving equations, we can use factoring to do that. We want to make sure the equation's set equal to 0. And then we're going to see the factoring like we saw in those previous problems. So this is set equal to 0, so that's good. Now I'm going to look for a common factor. So my common factor here would be a 2x. So I factor out a 2x, and I'll have x squared minus 16 equals 0. And I can recognize a difference of squares. We just saw this, so it's going to be 2x x plus 4, x minus 4 equals 0. If you recall, factoring works because now I take each factor and set it equals 0. 2x equals 0. X plus 4 equals 0. X minus 4 equals 0. Write out every factor equal to 0. Don't try and do it in your head. Don't try and think you can just make the answers from what you see. Write it out. Okay, write it out, and then you're going to have equations you should be able to solve and not make a mental mistake. I can subtract 4 on both sides here. I'm solving for x. Add 4 to both sides here. And I've got 3 answers now for this. I've got 0, -4, and +4. 3 possible answers that would solve that equation. All right, in number 6 here, we need to get it set equal to 0. So the first thing we're going to have to do is subtract 72 on both sides. So I'm going to subtract 72. And then when I rewrite this, I'm going to put it in standard form order as well. So I'm going to have w cubed plus 8w squared minus 9w minus 72 equals 0. Okay, right? I move the 8w squared. Keep the sign with it. It's a positive 8w squared, and it's a minus 9w. So now that I've got in standard form, so when I group it, it's 4 terms. There's no common factor to take out of all those terms, but I can group this. When I see the 4 terms, group that, and I'll have w squared, w plus 8, and I factor out a -9, and w plus 8 equals 0. So I'm going to have w squared minus 9, and w plus 8 equals 0. I want to recognize this is a difference of squares, w plus 3 and w minus 3. The w squared minus 9 is a difference of squares. Then w plus 8 equals 0. And I'm going to take each of those and set them equal to 0. So I'm going to write out w plus 3 equals 0, w minus 3 equals 0, w plus 8 equals 0. Subtract 3 on both sides, w equals -3. Add 3 to both sides, w equals 3, and subtract 8, -8. And I've got my 3 answers then, -3, 3, and -8. All right, and number 7. Get it set equal to 0, our first step. So I'm going to add 50y to both sides. Okay? And I'm going to get 15y squared plus 50y equals 0. Those are y's there. Okay. Now I want to look for a common factor. I can factor out 5w from each of these terms. So I factor, or 5y, not w, 5y. And I'm going to have 3y plus 10 equals 0. That's factored all the way, right? 5y's can't be factored anymore. 3y plus 10, there's no common factor. It's not a polynomial that can be factored anymore, so I'm going to set 5y equals 0. 3y plus 10 equals 0. Write it out, equal to 0. And then solve. I'm going to divide by 5 on both sides. I'm going to get y equals 0. Subtract 10 on both sides. 3y equals -10. And then I'm going to divide by 3. And when I divide this by 3 on both sides, I get y equals -10 over 3. Just keep it as a fraction. That's good. So I got 2 answers there, 0 and -10/3. Get it set equal to 0 and then use factoring. Number 8 here, we're going to see we need to get it set equal to 0. So we have to subtract 14x squared. I'm going to have 4x to the third. When I subtract my 14x squared, put it in standard form order, minus 8x equals 0. Look for a common factor. Our first step in factoring, look for a common factor. We have a common factor here of 2x. So I can factor out a 2x, and I'll have 2x squared minus 7x minus 4 equals 0. Then I would need to use the AC method. So AC method here for this one, I'm going to have AC equals -8. So I'm going to have 2x squared, and then my factors of -8 that add up to -7 would be -8x plus 1x minus 4. I'm going to group these, equals 0. I still would have a 2x here as well. Right? Bring that 2x down as one of my factors. We can bring it down at the end, that's fine, to make sure you don't forget it. All right, so now in that first parenthesis in green here, I'm going to factor out a 2x. I'm going to have x minus 4, and I factor out a 1 and have x minus 4, right? Sometimes it's just a 1 that can be factored out. That's fine. So I'm going to have 2x plus 1, x minus 4, and my 2x that I had at the beginning, don't forget that one as well. So 2x is also one of the factors. I'm going to set each of those equal to 0. I'm going to take 2x equals 0. 2x plus 1 equals 0. x minus 4 equals 0. When I divide by 2 on both sides, solve all these, x equals 0. Subtract 1, I get 2x equals negative 1, then divide by 2, x equals negative 1/2. Then add 4, and I get x equals 4. Each factor equal to 0. So when you're solving, set the equation equal to 0. Then use factoring, whatever different methods we have for factoring, and make sure every factor gets set equal to 0 to get your solutions. And if we want to check this, you can. Anytime you solve an equation, we could take those solutions, plug them back into the original equation, right? And they should make this true. If I plug any of those solutions in here, it should make this original equation true. All right, before we see another example and apply some of this, let's see a little trivia, a gold medal interlude. I'm going to break here with the Olympic symbol you see there. What's the significance for those 5 interlocking rings that we see so often, the Olympic rings? Well, it was originally designed in 1912 by the co-founder of the modern Olympic Games, Baron Pierre de Coubertin. Right? According to him, he came up with the design because all of the colors represented in that diagram, in that symbol, are part of a country's national flag. Every country at that time had at least one of those colors in their flag, so it brought together something symbolic of every country that was competing in the Olympics, kind of those interlocking rings, bringing everyone together as the world comes together for the Olympics. All right, let's look at one more example here and how we can apply something related to this factoring we've been learning. So we have a box, and the volume of a box is its length times its width times its height. Okay, so the volume of a box, it's called a rectangular prism. Okay, a rectangular prism would be like a box, any kind of cardboard box. You have a shoe box, anything like that, is length times width times height. So in this problem, they're telling us the volume is 72 cubic feet. The length is x. The width is x minus 1. And the height is x plus 9. Okay? And so now we have an equation we can solve. So to solve this, we're going to have to multiply all that together on the right side. Okay? We can multiply the x into the parentheses here to start. We get x squared minus x. Then we'd have x plus 9. And the 72 equals is still part of our equation. And then we can further multiply and distribute into the parentheses. So we can distribute the x squared into the parentheses. And we're going to have x squared times x squared times 9. Then we have negative x times x, negative x squared, and negative x times 9, negative 9x. And that equals 72. And then we can subtract the 72 on both sides and also combine these like terms. So we're going to get 0, because to solve it, we're going to need to have it set equal to 0. X cubed, okay, plus 8x squared minus 9x minus 72. And now we can factor this, and we can use grouping. So we're going to factor. We have 4 terms. There's no common factor of all that. We check that first. There's no common factor. So we're going to have 0 equals x squared, x plus 8. Then we're going to factor out a negative 9 and x plus 8. And so we're going to have x squared minus 9 and x plus 8 equals 0. And that first binomial factor, the x squared minus 9, is a perfect square. We can factor that one more step to x plus 3, x minus 3, right? Factoring completely equals 0. And then we set each factor equal to 0. So 0 equals x plus 3, 0 equals x minus 3, and 0 equals x plus 8. And when I subtract 3, I get x equals negative 3. I add 3, x equals 3. And subtract 8, x equals negative 8. Well, if you remember this back to a box, and the dimensions were, one of them was x. Okay, we can't have a length of negative 3. It can't be negative 3 feet or centimeters or inches or something like that. So x can't be negative 3 or negative 8. So 3 is our only solution that would actually work. Right? If we come back up here, we had a box. So the length, the width, and the height. The length would be x. So it was 3 feet. The width, right, was x minus 1. So 3 minus 1 would be 2 feet. And the height would be x plus 9. So 3 plus 9 would be 12 feet. So our box would have dimensions 3 feet by 2 feet by 12 feet. Right? So we set up an equation. We solved it, right, by getting it set equal to 0 and using factoring. Remember, when you're factoring, look for common factors. Look for special factoring patterns. Then factor if it's 3 terms or 4 terms, how we factor those, possibly the AC method. And make sure you always are looking to factor completely. And if you're solving, set every factor equal to 0 to come up with those solutions.